Hello and welcome back to my Calculus 3 or multivariable calculus problem solving series. In this video we're going to find the equation of a tangent plane to a surface. So this problem asks us to find the tangent plane to the surface f of x comma y, which equals negative x squared minus y squared plus 5 at the point 1 comma 0 comma 4. So this is the surface, and we want to find the tangent plane at the point 1, 0, 4. And this tangent plane only touches or intersects with the surface at this point. So how do we find the tangent plane? Well, to find the equation of a plane, we need to find the normal vector. And to find the normal vector, we're going to use something called a gradient. So what is a gradient? If you have a function of 3 variables, the gradient is a vector field where the component, the x component, is the x derivative, the y component is the y derivative, and the z component is the z derivative of the function f. And gradients, the vector for gradients, is always perpendicular to level surfaces. So that's important for what we're going to do next, to try to find the equation for our plane and find the normal vector for our plane. So using our previous function, surface, we can construct a new function, capital F, which has 3 inputs, x, y, and z. And this is a level surface where it's going to be f of x comma y minus z. And we're going to use this to find the normal vector. So our function f, capital F, will be negative x squared minus y squared plus 5 minus z. And this is going to be our level surface, which we take the gradient of to find the normal. So the x derivative of f is negative 2x. The y derivative is negative 2y. And the z derivative is negative 1. So our gradient is going to be negative 2x comma negative 2y comma negative 1. And our gradient at the point 1 comma 0 comma 4 will be negative 2 comma 0 comma negative 1. And this vector will be perpendicular to our surface, our level surface. And the level surface, which we have, is our function z equals minus x squared minus y squared plus 5. So at the point 1 comma 0 comma 4, the vector negative 2 comma 0 comma negative 1 is perpendicular to our surface. So now we have our normal vector, negative 2 comma 0 comma negative 1. And also remember that the equation for a plane is a times x minus x0 plus b times y minus y0 plus c times z minus z0 equals 0, where a, b, and c are the components of the normal vector, and x0, y0, and z0 are our point. So when we plug in the numbers, we get negative 2 times x minus 1, and since the y component is 0, there's nothing there, minus 1 times z minus 4 equals 0. And then when we distribute, we get negative 2x plus 2 minus z plus 4 equals 0. And we can rewrite this as our equation for the plane, which is 2x plus z equals 6. And this will be our equation for the tangent plane to the surface at this point. That's all for now. Thanks for watching.